Hello everybody, welcome to my channel. I'm Joan Amara. If you're just joining me for the first time, please subscribe to my channel, and I believe you will like this video, so give it a thumbs up as you watch. Thank you. Today we are going to be learning about parametric curves, just the basics introduction. What we are going to just do in this video is simply know what parametric curves are and why are we doing parametric curves. Can't we just stick to functions? Why are we parametrizing? So that is what we're going to be doing today. So let's see, what is a parametric curve? So if you're given a curve like this, if you observe, this is some x, this is our x-axis, and this is our y-axis, okay? And you know that in the real sense, this is actually our domain, right? While this is our codomain. Now, if we take this x naught here, we see that this x naught hits this curve at two places. So it has two images. Let's call this y naught and call this second point it hits y1. So a question that comes into our mind is, can I call this a function? Before we answer this question, let us find out what a function is. So what is a function? So a function is a mapping that assigns elements in the domain to unique elements in the codomain. So if I have a mapping, I need to look at the domain. Is it that every element that has an image, okay, every element in the domain, is it assigned to a unique element in the codomain? That if I look at the codomain now, will that element in the domain give me only one element in the codomain? Let's see that curve again. So looking at this curve, is this curve a function? So look at an element in the domain. Does it produce only one element in the codomain? As you can see, it produces y0 and it produces y1. So it doesn't produce a unique element in the codomain. And you can see that happening at every point in this side, even in this side up to here. So you can see that this is not a function. So when we have a curve like this, to be able to work easily with it, we have to introduce what we call parametrization. And that is what we call making elements in this domain a function of a new variable, say t, and then this one making elements in the codomain a function of t also. So both x and y will be a function of a single variable, and that is what we call parametrization. So this t is called the parametrization variable, and it is always over an interval, say I. So the interval actually tells you where you are starting from, this starting point, okay? So if the interval is a comma b, okay, so the first point is always x a comma y a. So that's all you have here, okay? That's the coordinate of that place, while your last point here is going to be x b comma y b. So that is all concerning what you need to know about the basics of parametrization. All I think you need to know about the basics of parametrization. So number one, usually it can be a function, right? But what prompted us to start parametrizing is that when we have a curve that is not a function, we have troubles working with it. So instead of having that troubles, we parametrize the curve, okay? Number two, to parametrize a curve, you must introduce a new variable in which x will be a function of that variable and y will be a function of that variable. So both x and y are the function of that parametrization variable, okay? And then finally, c is always given over an interval I, okay? And I has a starting point a, okay, and ends at b. So the first point, the starting point of your curve is your x a y a coordinate, and then the end point is your x b y b coordinate. Thank you for watching. Please subscribe to my videos and hit the notification bell. Thank you.